In the realm of equipment malfunctions, some breakdowns defy logic and leave you scratching your head. Let's delve into a collection of the most unbelievably stupid breakdowns, exploring the bizarre reasons behind their failures. The winner of the most stupid breakdown award goes to the incident involving a piece of foam rubber pipe insulation lodged inside a gas pipe. This intrusion caused the flame to blow out, leading to a perplexing situation for the homeowner. The story unfolds with someone experiencing furnace problems, specifically the flame repeatedly blowing out. After initial checks, the decision was made to replace the gas or pilot control valve. During the replacement process, the union was detached, revealing the unbelievable culprit: a piece of foam rubber pipe insulation obstructing the gas pipe. The baffling question arose: how did this piece of insulation find its way inside the pipe? It's speculated that the insulation had been present within the main gas pipe for an extended period, possibly 30 or more years, gradually making its way into the 3/4-inch pipe and subsequently into the 1/2-inch pipe. To address the issue, the 165° Fahrenheit high limit switch was replaced with the 170° Fahrenheit one. The furnace's highest rated limit switch is 200° Fahrenheit. There's suspicion that the original installer might have tried to compensate for low gas pressure caused by the insulation by using higher British thermal unit burner orifices. However, a thorough check of the burner orifices is planned for the summer. The occupants had grown accustomed to the furnace running constantly, so they mistakenly reported false callbacks when the thermostat correctly stopped calling for heat, mistaking normal operation for another breakdown. As runners-up, there is the tale of a television refusing to power on due to a simple issue: dust and a dirty fuse. The initial problem involved the television's power relay clicking and then dropping out. The individual, drawing from experience with water-level switches and washing machines malfunctioning due to metal oxides on terminals, took a proactive approach. The television was unplugged and the interior was dusted. The fuse was removed, cleaned along with its holder using a tissue, and then reassembled. Miraculously, the television sprang back to life, working perfectly. And thirdly, there is the incident of a machine malfunctioning because the operator simply forgot to turn on the power. Back in the fall of 2001, a machine operator at a factory experienced a day where troubleshooting was needed because they had overlooked turning on the machine's power supply. The importance of ensuring that machines are properly plugged in and powered on cannot be overstated, and it's equally crucial for operators to press the correct buttons. Even experienced operators can have occasional lapses in their routine. These stories serve as reminders that even the most experienced individuals can encounter moments of oversight or face seemingly inexplicable equipment malfunctions. Let's explore some more common causes of equipment breakdown and how to prevent them. Firstly, improper maintenance is a leading cause of equipment failure. Neglecting routine maintenance tasks such as lubrication, filter changes, and inspections can lead to accelerated wear and tear on components, increasing the likelihood of breakdowns. Secondly, overloading equipment beyond its rated capacity can also result in premature failure. Exceeding weight limits, voltage ratings, or duty cycles can stress components and lead to overheating, damage, or complete failure. Thirdly, environmental factors such as temperature extremes, humidity, dust, and corrosive substances can degrade equipment performance and lifespan. Protecting equipment from these environmental hazards is essential for preventing breakdowns. Fourthly, inadequate training and operator error can contribute significantly to equipment malfunctions. Operators who are not properly trained on equipment operation, maintenance, and troubleshooting procedures are more likely to make mistakes that can lead to breakdowns. Fifthly, vibration and shock can cause damage to sensitive components and connections in equipment. Implementing vibration isolation measures and securing equipment properly can help prevent vibration-related failures. Sixthly, corrosion can weaken metal components and electrical connections, leading to equipment failure. Applying protective coatings, using corrosion-resistant materials, and implementing regular inspections can help mitigate corrosion-related issues. Seventhly, electrical surges and voltage fluctuations can damage sensitive electronic components in equipment. Installing surge protectors and voltage regulators can help protect equipment from electrical disturbances. Eighthly, Neglecting to address minor issues promptly can lead to more significant problems down the road. Addressing small leaks, loose connections, or unusual noises early on can prevent them from escalating into major breakdowns. Ninthly, using incompatible or substantive replacement parts can compromise equipment performance and reliability. Always use genuine or approved replacement parts that meet the manufacturer's specifications. Tenthly, inadequate cooling can cause overheating and damage to equipment components. Ensuring proper ventilation, airflow, and cooling systems can help prevent overheating-related failures. In addition to these common causes, equipment breakdowns can also occur due to unexpected events such as power outages, natural disasters, or accident. Developing contingency plans and backup systems can help minimize downtime and mitigate the impact of these unforeseen events. To prevent equipment breakdowns, it is essential to implement a comprehensive maintenance program that includes regular inspections, lubrication, cleaning, and component replacements. Training operators on proper equipment operation, maintenance, and troubleshooting procedures is also crucial. Furthermore, monitoring equipment performance, identifying potential issues early on, and addressing them promptly can help prevent major breakdowns and extend the lifespan of equipment. By addressing the common causes of equipment breakdowns and implementing proactive maintenance practices, organizations can minimize downtime, reduce repair costs, and improve overall equipment reliability. Now, let's consider some preventative measures to mitigate these risks. Implementing a structured maintenance program is key. This involves scheduling regular inspections, lubrication, filter changes, and component replacements. A well-defined maintenance plan ensures that equipment receives the necessary care to prevent premature wear and tear. Proper operator training is also paramount. Ensuring that operators are thoroughly trained on equipment operation, maintenance procedures, and troubleshooting techniques reduces the likelihood of human error leading to breakdowns. Well-trained operators are more likely to identify potential issues early and take corrective action. Monitoring equipment performance is another important aspect of prevention. Monitoring key performance indicators such as temperature, pressure, vibration, and electrical parameters can provide early warnings of potential problems. Implementing a monitoring system allows for timely intervention and prevents minor issues from escalating into major breakdowns. Environmental control is also crucial. Protecting equipment from environmental factors such as temperature extremes, humidity, dust, and corrosive substances helps to prevent degradation and corrosion. Providing adequate ventilation, filtration, and environmental controls can significantly extend equipment lifespan. Furthermore, using quality replacement parts is essential. When replacing components, using genuine or approved replacement parts that meet the manufacturer's specifications ensures compatibility and reliability. Substandard or incompatible parts can compromise equipment performance and lead to premature failure. Addressing minor issues promptly is also critical. Addressing small leaks, loose connections, or unusual noises as soon as they are detected can prevent them from developing into more significant problems. Ignoring minor issues can lead to cascading failures and costly repairs. Implementing vibration isolation measures can help to prevent vibration-related failures, especially in equipment with sensitive components. Proper mounting and securing of equipment can reduce vibration levels and extend component lifespan. Electrical surge protection is also important, especially for equipment with sensitive electronics. Installing surge protectors and voltage regulators can protect equipment from damage caused by voltage spikes and power fluctuations. Furthermore, developing contingency plans can help to minimize downtime in the event of unexpected equipment failures. Having backup systems, spare parts, and emergency procedures in place can ensure business continuity and reduce the impact of breakdowns. Regularly reviewing and updating maintenance procedures is also essential. As equipment ages and operating conditions change, maintenance procedures may need to be adjusted to ensure optimal performance and reliability. Regularly reviewing and updating maintenance plans can help to adapt to changing circumstances and prevent breakdowns. Additionally, implementing a computerized maintenance management system (CMS) can streamline maintenance operations, track equipment performance, and schedule preventive maintenance tasks. A CMS can help to optimize maintenance efforts and improve equipment reliability. By implementing these preventative measures, organizations can reduce the risk of equipment breakdowns, minimize downtime, and improve overall equipment performance and lifespan. Equipment breakdowns can have significant impacts on businesses and operations, ranging from financial losses to safety hazards. Understanding the various types of impacts and their potential consequences is essential for developing effective prevention and mitigation strategies. Firstly, financial impacts are among the most immediate and tangible consequences of equipment breakdowns. These impacts can include direct costs such as repair expenses, replacement costs, and labor charges, as well as indirect costs such as production losses, downtime, and missed deadlines. Equipment failures can disrupt production schedules, delay deliveries, and lead to customer dissatisfaction, resulting in lost revenue and damage to the company's reputation. Downtime, in particular, can be extremely costly, especially in industries where equipment availability is critical for maintaining productivity and profitability. Secondly, operational impacts can also be significant. Equipment breakdowns can disrupt normal operations, causing delays, bottlenecks, and inefficiencies in production processes. In some cases, equipment failures can lead to complete shutdowns of entire production lines or facilities, resulting in significant disruptions to the supply chain and increased costs. Operational impacts can also include increased workload for maintenance personnel, as they must scramble to repair or replace faulty equipment and restore operations as quickly as possible. Thirdly, safety impacts are a major concern, especially in industries where equipment failures can pose a risk to the health and safety of workers. Equipment malfunctions can lead to accidents, injuries, and even fatalities, resulting in significant human costs and legal liabilities. Examples of safety hazards caused by equipment breakdowns include malfunctioning machinery, electrical faults, and chemical leaks. Preventing equipment failures and ensuring a safe working environment is essential for protecting workers and minimizing the risk of accidents. Fourthly, environmental impacts can also be a concern, especially in industries that handle hazardous materials or operate in environmentally sensitive areas. Equipment breakdowns can lead to spills, leaks, and emissions of pollutants, causing damage to the environment and potentially violating environmental regulations. Cleanup efforts, remediation costs, and fines for environmental violations can be significant. Implementing preventive measures and emergency response plans is essential for minimizing the environmental impacts of equipment failures. Fifthly, reputational impacts can also be significant. Equipment breakdowns can damage a company's reputation and erode customer trust. Customers may lose confidence in the company's ability to deliver products or services reliably, leading to decreased sales and market share. Negative publicity surrounding equipment failures can also harm the company's brand image and make it more difficult to attract and retain customers. Building a reputation for reliability and quality is essential for maintaining customer loyalty and competitiveness. Sixthly, legal impacts can also arise. Equipment breakdowns can lead to legal liabilities and regulatory penalties. Companies may face lawsuits from customers, employees, or regulatory agencies if equipment failures result in injuries, damages, or violations of laws and regulations. Legal costs, settlements, and fines can be significant. Complying with all applicable laws and regulations and maintaining adequate insurance coverage is essential for mitigating legal risks. Seventhly, compliance impacts can occur. Equipment breakdowns can also disrupt a company's ability to comply with industry standards and regulations. Failure to meet regulatory requirements can result in fines, penalties, and loss of certifications, which can impact the company's ability to operate legally. Implementing robust maintenance programs and ensuring compliance with all applicable standards and regulations is essential for avoiding compliance issues. Eighthly, employee morale impacts are a factor. Equipment breakdowns can negatively impact employee morale and job satisfaction. Workers may become frustrated and demoralized if they are constantly dealing with malfunctioning equipment and production delays. Providing employees with the training, tools, and support they need to perform their jobs effectively is essential for maintaining morale and productivity. Ninthly, supply chain impacts can occur as well. Equipment breakdowns can disrupt the entire supply chain, affecting suppliers, manufacturers, distributors, and customers. Delays in production and deliveries can lead to shortages, increased costs, and dissatisfied customers. Maintaining strong relationships with suppliers and implementing contingency plans can help to mitigate supply chain disruptions. Tenthly, insurance impacts come into play. Equipment breakdowns can affect a company's insurance premiums and coverage. Insurers may increase premiums or reduce coverage if a company has a history of frequent equipment failures. Implementing preventive measures and demonstrating a commitment to safety and reliability can help to reduce insurance costs. By understanding the various types of impacts associated with equipment breakdowns, organizations can develop comprehensive prevention and mitigation strategies to minimize their potential consequences and protect their operations, finances, safety, environment, reputation, and compliance.